Now, when we're solving equations, if you remember, we use some manipulatives for those of you who are here, but I know a lot of you who are watching this might have been absent. What we're always trying to do is get the variable by itself because we want to see what it's equal to. And remember, an equation is like a seesaw or a balance scale. If I do something to one side, it's going to cause it to tilt in that direction. I got to keep it balanced. That's what the equal sign means, is that the two sides are equal. So if I do something to one side, I got to do it to the other. So if I want to get x by itself, I say I've got a minus 3 with it. So we always do the opposite operation. I'm going to call that the opposite thing. X has got to subtract 3 with it. What's the opposite of subtracting 3 from x? Adding 3. Okay, so adding 3. So what I'm going to do, if I do it to one side to keep the equation balanced and equal, I need to do it to the other side. So I'll add 3 to both sides. Now, the reason that works is if I were to write this as 3 minus 3, you would know it was 0, right? Just because it's written like this, it doesn't mean it's any different. It's still 0. These things are going to add up to 0. A plus 3 and a minus 3 add up to 0. We saw that because we used some manipulatives in class on Tuesday. They cancel out. They add up to 0. I could put x plus 0, but lazy math guy usually just writes x, so that's what I'll eventually do. Now, on the other side, I need to total up what I have. What's 12 plus 3? 15. So x is 15. There's our answer. We always are looking for what we need to do to get x by itself. When we do something, we have to do it to both sides, and we're always doing the opposite thing. And there was one other thing we talked about with our manipulatives that I'm just meant to mention here. If there's more than one thing to do, which in today's lesson I don't think they give you very many like that. I don't think they give you one like that, number 17. If there's several things that we have to do to get x by itself, what we do, we write PEMDAS down, but we go backwards to figure out what to do first. So we're going to talk about that on problem number 17 in a minute. Here, there's only one thing to do, so we don't even have to think about it. 2 looks a little different. There's something, the reason I wanted to do 2 before some of the requested ones, and actually, the reason I wanted to do this one first is what do you do when you get something like this? Did they write that as simply as they could? No. No. What could we clean up here? It's like a cleanup thing we could do here. 20 plus 5. Yeah. Let me rewrite it. On the other side, 20 plus 5 is 25. It would be better if I do that. Anytime we're solving equations, we should always simplify each side first. And so they're going to throw you a lot today where they didn't do that, because they want you to get used to doing some cleanup work before you start solving. So always simplify each side first if you can. Like here, we could put 20 plus 5 and write 25. Do that first, then start solving. Always you should do that. It will make your life so much easier because you've cleaned it up where there's less to do. It's kind of like walking into a dirty room and needing to kind of clean it up before you start vacuuming or something, you know. All right. Is y by itself? Because that's what I need. Is it? No. What's it got with it?
It's got an addition of y sign.
It's got plus 6. Okay, plus 6. What's the opposite of a plus 6?
Subtract.
Subtract 6. Chester is in fine form today, for those of you who are not here. He is like making up his own words. So 6 minus 6 is 0. I could put y plus 0, but isn't y plus 0 just y? So a lot of times we don't write it down because if I could, and then I'd have to write y on the next line. What's 25 minus 6?
19.
19. Oh, we're done, aren't we? Y is 19. We just solved it. So we said, what's with the y? Get rid of it by doing the opposite operation or the opposite thing. We said the opposite of a plus 6 is a minus 6. So that's how we were thinking here. They start you off with a lot of problems that have one thing to do to them. Most books would have done this differently. This book kind of has you doing a lot of things in the first lesson. This book kind of just jumps right into solving equations, and it's not bad. You can figure it out. Here's an m. Is that m by itself? No. What does it have? What's being done to it?
It's being multiplied by 8.
Yeah, it's multiplied by 8, and we know that because they squished it, right? When they squish stuff together, that means multiplying. We have to remember that. So what's the opposite of multiplying something by 8? Dividing it by 8, okay? So that's what I'm going to do. To get rid of the number that's with the m, I do the opposite thing, and that gets rid of it. If I divide it by 8, remember, if I do it to one side, I got to do it to the other. Yeah, good, okay? So now let's reduce this. 8 goes into 8 one time. 8 goes into 8 one time. Do you see why dividing by 8 got rid of the 8s? Because now we have 1 over 1m, which is 1m, and lazy math guy doesn't want to write that down. He says, oh, that's just m. And what's 24 divided by 8? 3. Oh, you just solved it. M is equal to 3. By keeping it balanced, by doing things to same thing to both sides, and by doing the opposite thing, we can get through this. I'm going to pick some various ones, and I'll open it up for questions, but I see some that I know that people are going to have problems with, so I may not pick yours, and if you'll hold questions, we'll do those. All right, so let's look at number 6. 2/5 x, if you will hold questions, unless you're asking a question about the particular problem I'm on, I will get to your questions after the video. Remember, I just said that, okay? Is x by itself? No. Oh. Well, we'll think about that. But first of all, is there any cleanup work to do here? Yes. What can I clean up?
9 minus 5.
Yeah, 9 minus 5 is what? 4. We always clean up for what goes on here. So I'm going to show you why we might want to leave this as a fraction. X is not by itself. I already cleaned it up, right? Now, x is multiplied by 2/5, and the opposite of multiplying would be dividing by 2/5, but wouldn't that be ugly? There's an easier way to do it. What would happen, let me just show you what you're going to do, and you tell me, what would happen if I took this 2/5 and I flipped it upside down and I multiplied by it? And remember, if I do it to one side, I got to do it to the other, so I'm going to go ahead and write it over there. On the left-hand side, what happens to those 5s and those 2s if I multiply by the reciprocal, if I flip the fraction upside down and multiply by it?
It's 1.
Yeah, look at that. 2 goes into 2 one time, 2 goes into 2 one time, 5 goes into 5 one time, 5 goes into 5 one time. I got a stray mark on my paper. On top, 1 times 1 is 1. And I'll go ahead and write it down just so we can see this. And on the bottom, 1 times 1 is 1. I have 1 over 1x, which is just 1x. And lazy math guy is just going to write an x. Do you see how if I do that, it gets rid of everything? And I didn't even have to say like, I didn't even have to convert it to a decimal. And here's where it might come in. You might can see a little bit of why it might be handy on the other side. If I had to multiply both sides by 5/2, right? What if I put the 4 over 1 and I want to simplify this other side? This is 4 over 1 times 5/2. Do you remember that I can reduce? I can say, oh, 2 goes into 2 one time and 2 goes into this 4 2 times. So I'll do it over here now. It just wasn't written out maybe as nicely as I wrote it over there. What would you have as your answer? On the top of that fraction, you have 2 times 5 is 10. On the bottom, you have 1 times 1 is 1, and 10 over 1 is, ooh, look at that. Now to number 17. I can only record a 10-minute video. That's why I'm asking you all to wait on your questions, okay? And then I'll get back to you just after this video. Okay. Here is number 17. Look at it, gross. But you know that saying, how do you eat an elephant one bite at a time? That's how you look at equations. You do one little thing at a time. Now remember, when I'm solving equations, first of all, is there anything I can simplify here? Is there any cleanup work? There's not any numbers to add together like they did on some of the previous ones that we looked at on the video, are there? Now, okay, so then I go, all right, is b by itself? No. It's got a half multiplied by it, and it's got a plus 6 on it. How am I going to know what to do first? PEMDAS backwards. When we simplify, we do PEMDAS in order. When we solve, we just go backwards. It's kind of like undoing something somebody, did. All right, so that means I'm going to check first. Is there anything I can add or subtract? I'm looking for an add or subtract sign basically in the problem. Isn't there a plus 6?
Yeah.
So I could do the opposite of it. What would be the opposite of a plus 6? Yes, I'm doing the opposite operation. If I'm being all mathy here, I'm doing the opposite operation. The opposite of a plus 6 is a subtract 6. And so if I do it to one side, I gotta do it to the other side. I'm going to say that a lot just because hopefully it'll help you remember to do that. And you see how I put that line through my equal sign? That was just to help me see that I actually did the same thing to both sides. And you don't have to do it. It just helps some people. Well, a plus 6 and a minus 6 add up to 0, so I could write it as a half b plus 0, but lazy math guy would just put down a half of b, wouldn't he? Now, on the other side, let's clean it up as we go. What's 11 minus 6? Isn't that just 5?
Yeah.
Okay. All right, so I'm just going to write that here. Now I go back and I look. Is my variable by itself yet? Nope. Now I got a half times b. I could divide both sides by a half. I could divide both sides by 0.5, but what we saw in a previous problem is kind of a nice way to take care of this without having all these decimals, is to multiply by the reciprocal. And the reciprocal is if I take that fraction out front and I just flip it over. And if I do it to one side, I gotta do it to the other side. So I'm gonna go ahead and write it over there. Now that cleans it up faster, because look, the 2's cancel out. 2 goes into 2 once, 2 goes into 2 once. And all I've got is 1 over 1b, which is just my b, right? Lazy math guy would just say, hey, write b. Now on the other side, I got a number times a fraction. If you don't like that, if that confuses you, couldn't you make this 5 into 5 over 1? Right, and that would make it 2 fractions multiplied together. On the top, you'd have 5 times 2 is 10. And on the bottom, you'd have 1 times 1 is 1. Would lazy math guy write 10 over 1? How would he write it? 10. And you're done. Okay, so you have to do things in a certain order. It's not that I couldn't have multiplied everything by 2 first, but if I had done it, a lot of times when you mess with the multiplication divide part first, you make a big mess of fractions. Not always, but sometimes, and so that's why we do PEMDAS backwards. It just tends to keep it the simplest way we could see it, so that we don't have to have a lot of confusing stuff to look at. Now, on number 20, this is what you got here. Do you remember that we should always simplify or do any cleanup work we can first? Is there any cleanup work we could do here?
No.
Oh, there is.
Yeah, no.
Look at these x's. They're like terms, aren't they?
Yeah.
We just had a test where y'all had some things where you had to add like terms, and I know sometimes some of y'all got confused on that, but remember, if it's the same letter with the same exponent, in this case it's the invisible 1, we can put these together. So really, if you remember what I do is if I've got like terms and I add them, I write down the term x, and I add the numbers out front. What's 2.5 plus 1.0? Yeah, y'all know how to add decimals, right? So you see how even in equations you might get something like this. 3.5x is equal to 7 is what this problem really is. Now, if you got a decimal in the problem, it's okay to keep working with it as a decimal. If they give it to you as a fraction, try to always keep it as a fraction because it usually works out better that way. Here we got a decimal, so we don't really, we could change it into a fraction, but most people don't want to do that. So it's okay to divide both sides by a decimal. It's just that we try not to unless we have to, okay? How am I going to get, isn't this 3.5 multiplied by the x? Yeah, because it's smushed together, right? So what's the opposite of taking something and multiplying it by 3.5? Yeah, dividing by 3.5. So that's what I'm going to do. If I do it to this side, though, I got to do it to the other side, okay? Now, these cancel out, and I'm just left with x. So, yeah, you could divide by a decimal. Now, 7 divided by 3.5, do y'all remember that if you took 7 and split it in half, wouldn't it be 3.5 or 3.5? It's 2. You could get a calculator out if you needed to, but that answer is just going to be 2, and you would be done.